Engine operation is monitored with three instruments: the oil pressure and oil temperature indicator, the tachometer, and the exhaust gas temperature indicator. An oil pressure line is routed from the upper front of the engine case to the rear engine baffle. At the baffle, the oil pressure line is connected to a transducer. The transducer produces an electrical signal, which is translated into a pressure reading by the oil pressure gauge. A resistance type probe is located in the engine accessory case. Probe resistance changes as oil temperature changes. Resistance is translated into oil temperature readings on the oil temperature indicator. Oil is drawn from the engine sump through an oil suction strainer screen
The airplane to move it through the air. It also has other components attached to it in order to create electricity, vacuum suction, and heat, just to name a few. The power plant of an airplane, like an engine of a car, is one of the most important components, because without it, there is no way to get the plane off the ground. Aviation engines can be separated into two groups: reciprocating engines and turbine engines. While most airlines and corporate airplanes use turbine-powered airplanes, general aviation and training aircraft are equipped with reciprocating engines. Reciprocating engines have several cylinders. Inside of those cylinders, fuel and air are mixed, compressed, and then ignited. As this fuel-air mixture is ignited, its explosive force moves the piston inward. These pistons are connected to a crankshaft, and when the pistons move in and out, that causes the crankshaft to rotate. The propeller is connected to the crankshaft, so as the crankshaft rotates, so does the propeller. The cylinders undergo a continuous four-stroke cycle. The four strokes are called intake, compression, power, and exhaust. The first stroke, the intake stroke, is when the piston inside the cylinder moves away from the cylinder head. As the piston moves away, the intake valve opens, and the fuel-air mixture is sucked into the cylinder's combustion chamber. Once the piston has reached the base of the cylinder, it's time for the second stroke, compression. During this phase, the intake valve is closed, and the piston reverses direction, moving back towards the cylinder head. This compresses the fuel-air mixture, since it has nowhere to escape. Once the piston approaches the top of the cylinder, we begin the third stroke, power. Two spark plugs at the head of the cylinder each let off a spark, which ignites the fuel mixture and makes it combust. This controlled explosion pushes the piston back inward towards the base of the cylinder, which in turn rotates the crankshaft, and therefore the propeller. Finally, we reach the last stroke, exhaust. During this phase, the exhaust valve opens, and the piston moves back towards the cylinder head, pushing out the combusted gases, commonly called exhaust. Then the process starts all over again, repeating the process thousands of times every minute. On a typical four-cylinder engine, each one of the cylinders is in the middle of a different stroke. That way, one cylinder is always in the power stroke, and the engine is able to keep the crankshaft rotating, thereby allowing the remaining cylinders to go through their respective stroke. As we just saw in the